Hi everyone, in this video we are going to discuss chemical formulas. So chemical formulas are essentially just a shorthand notation, or it's a very easy way for one scientist to tell another scientist a very good description about the specific molecule they were talking about. So for example, if I were to yell across the room the phrase carbon dioxide, I would be telling my friend or my coworker or whatever that I am talking about a molecule that has the element carbon. And then oxide, I'll tell you how to kind of decode these words in just a second. But oxide is actually a shorthand for oxygen. And then we have the phrase di, which is just something that we put in front of the word to indicate that we have two. And so right away, hopefully, you would be able to say, okay, I know that we are talking about the elements carbon and oxygen. It looks like we have them in a 1:2 ratio. So if I were to write down a chemical formula, it would represent something like CO2 or carbon dioxide. So hopefully you already know that one. But it's just a very, very easy way to describe a 1:2 ratio of carbon to oxygen. Now let's try another one. What if I yelled out dihydrogen monoxide? So di, we just discussed, that means two. Hydrogen, that's pretty clear, it's hydrogen. Mono is just another word for one. And then oxide, we said again, was oxygen. So again, right away, you could say that we are discussing something that has to do with hydrogen and oxygen. Those are our two elements present, and they are in a 2:1 ratio. So if we were to put a formula to this, we would just say H2O, also known as water. And we will see this time to time again, that there's a word, a colloquial term that we as humans discuss for some kind of formula, probably more like ozone. We'll talk about that again. But there's also a more technical word, or a better way that we could describe that, which would be dihydrogen monoxide. So another thing I want to point out while we're talking about chemical formulas is these things called diatomic molecules. And so what we need to express, or what I really need to tell you, is that some elements exist naturally, so in their standard state, so at regular temperature, so like 25 degrees or whatever, and then atmospheric pressure. There's some of these exist naturally as diatomic molecules. So what that means is that there are some elements that you are never, ever, ever going to find as a monoatomic as one thing. So for example, palladium is monoatomic, zinc is monoatomic, there's just one element. But diatomic means two atoms. And so for example, nitrogen is one of these. So you're never going to see me write nitrogen as a plain old one monoatomic element, just nitrogen like this. It will always have two of them together. And so there's 7 different ones that I need you to know. And so I learned them back my sophomore year of high school as the Brinkelhoffs. So Br, bromine, INCLHOF. So there's 7 different ones that you absolutely have to memorize. No exceptions. You have to get this down. So let's talk about this. This is bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. You absolutely need to know that you are never, ever, ever going to see oxygen as just plain O like this. You are always going to see it like this as O2, as a diatomic molecule. Same thing for nitrogen, like I just discussed. You're never going to see it as a plain N. It is always going to be N2. All right, so let me leave you with one question here just to make sure we're all on the same page. And so here it is. Does boron exist naturally as a diatomic molecule? Good luck!